Right, what we have here, it's actually a sequences question, but it's quite heavily disguised in context. But we've got an initial amount of wheat harvest, 2,100 tonnes in 2017. And then it says the mass is expected to increase by 1.2% per year. And that's got to trigger in your mind the idea of a geometric sequence. It's like interest in the bank. 1.2% interest on your money is exactly the same as 1.2% growth in this harvest of wheat. That's always a geometric situation. Okay, so we need to think about geometric sequences. The formulae that we have, and in fact part A is asking us for a total mass of wheat, so we need a sum formula. So let's just remind ourselves on the side, the sum of a geometric series, we have this formula that we can use. So I think if we identify the right data, we should be good to go. Now we have years here, so a bit of advice is to write down a couple of examples. So 2017, that's U1 in the sequence, it's the first term in the sequence, and the harvest was 2,100. 2018 will be the next term, so that'll be U2 in the sequence. I'm not going to work out the exact value, but it's 2,100. To increase by 1.2%, we multiply by 1.012. That's how you do the percentage increase by multiplication. And then we want that pattern to continue until 2030, which is going to be U. Now you need to think carefully. 2017 was U1, 2018 was U2. We need to subtract 16 off the end of the year to convert it into a sequence number. So the end of the year is 30, subtract 16, that'll be U14. Okay, so we're actually looking at 14 terms in this sequence. So in sequence notation, A for the formula will be 2,100. R, the rate or the ratio, is 1.012. N, the number of terms, we've just worked that out to be 14 terms. So we can use the sum formula now. The sum of those 14 terms is A 1 minus R to the power N over 1 minus R. Grab your calculator, type it in, and you should get 31806.99. So I want to double check that. Let's think about accuracy here. The question asks us to give it to 3 significant figures, so we'd lose a mark if we didn't do that. So the first 3 significant figures are 318, and then we just round that off to an integer, so 31800 tons, and that's 3 SF. Okay, that's part A done. That's the total wheat harvest in those 14 years. I've put this graph on the sides, just used Excel to plot this data. So you can see we've got the years down the side from 2017 to 2030. Excel's calculated how much in each individual year and plotted those, but their total agrees with ours, that value of 31806.99. Okay, the graph looks almost like a straight line, but it won't be. Geometric growth is always, it might be a slow curve, but it is always going to be a curve. So I'm going to exaggerate it, but this trend is curving exponentially upwards. It's because it's only 1.2% that we don't really see the shape of that curve very clearly. Okay, let's look at part B. Notice that there's some extra story given before you read the question part B. So let's check the extra story. Each year it costs £5.15 per tonne for 2,000 tonnes and £6.45 per tonne for everything over that. Okay, now notice every year the amount we harvest is over 2,000 tonnes, because if I draw 2,000 tonnes across the Excel graph, that's a cut-off down there. Every year we're producing more than that, so every year we're going to be paying the higher rate on most of what we grow. There's several ways we could solve this. I like to think of it as a total and a discount. So imagine to start with, imagine we had to pay that £6.45 on everything we produced. Okay, so imagine we had to pay £6.45 per tonne on 31,806.99 tonnes. Remember to keep those exact values. Well, that would cost us 205,155.10. Okay, it's just multiplication. The cost per tonne multiplied by how many tonnes there were. Now, we actually get a discount. The discount we get is 645 minus 515. So we get a discount of, that's £1.30, the difference there. And we get that discount on 2,000 tonnes of wheat each year. So it's £1.30 per tonne on 2,000 tonnes. So that's how much discount there is in 1 year, and the next year, and the next year, and that's the same in all 14 years. So if we multiply those together, we get a total discount, or a saving, and that's 36,400. And so if we subtract our total price minus that discount, we'll be left with what the actual cost is. And that turns out to be 168,755.10. And again, checking the question, it wants the answer given to the nearest £1,000. So we just need to round that. 1,000 separates there, so that's 169,000 to the nearest 1,000. Okay, if you want to see that on the graph, what we did was we took each blue bar standing in this graph. That's the total amount of wheat each year. And we multiplied that by 6.45 to work out the total cost if we had to pay the high rate. And then the subtraction we did, if I highlight them in red, was to take all these small sections. We get a discount on that part, and a discount on that part, and that part, and that part. And it's the same discount every year for 14 years. So we had a fast way to calculate that discount by doing that multiplication. The amount of the discount times 2,000 tonnes each year times 14 years.